All right, you are welcome again. Today, let's consider this problem. Differentiate from first principle y is equal to cos squared for x. Okay, now pay attention to this, it's very important. Okay, we are talking about derivative or differentiation using the first principle. This is different from the normal method everyone is using. Okay, and this one is also a bit different, so I want you to pay attention. When we are talking about first principle, we are talking about by definition. Okay, so what do we mean by definition? Now when we are talking about derivative, f prime of x is the limit as change in x approaches 0, f of x plus change in x minus f of x all over change in x. Okay, so this is the mathematical expression for derivative or differentiation. Okay, so by definition, this is what derivative is. Okay, now we are going to use this method to find the derivative of cos squared for x. Please, I want you to pay attention and let's do it gently. Okay, I will not be too fast and I will not be too slow at the same time. So the aim is for you to understand and understand it properly. Now let's go. From this definition where we say f prime of x is the limit as change in x approaches 0. Here we have f of x plus change in x minus f of x. So what is f of x? F of x is the function that we have, which is y. And it is the same as what? Cos squared for x. That is our function f of x, right? Good. What about x plus change in x? So in the function that we have, anywhere we see x, we are going to write x plus change in x into it. Okay, are we together? So here we have f of x plus change in x is equal to cos squared 4. In place of x now we write x plus change in x. Then you can also use this 4 to open the bracket. Okay, so that means we are going to have 4x plus 4 change in x. All right, so here we have defined the variable f of x and f of x plus change in x. Okay, so we are going to bring it into the definition that we have, which is equation 1. So bringing it into the definition where we have f prime of x is equal to limit as change in x approaches 0. In place of f of x plus change in x, we have cos squared 4x plus 4 change in x minus, in place of f of x, we have cos squared 4x all over change in x. Are we together? So we give this equation 2. Okay, now we are going to be using some few trigonometric formulas and they are very simple. Okay, now look at this. When you have something like cos squared x is the same thing as saying cos x times cos x. Cos x times cos x is the same as cos squared x, right? Good. And it's also the same as saying cos x all a bracket squared. I hope you agree with this, right? Yes, it's the same. Are we together? Yes. So here that we are having cos squared 4x plus 4 change in x. So we are going to put everything into the bracket, right? Raised to the power of 2. So that means we are going to have limit as change in x approaches 0, cos 4x plus 4 change in x, all a bracket, squared, minus cos 4x, all a bracket, squared, all over change in x. Hello, are we together? Yes. Now look at this. We call this equation 3. Now, if you look at this very well, you see what we are having here. Cos 4x plus 4 change in x in bracket squared minus cos 4x all in bracket squared, right? So remember what we call difference of 2 squared. Difference of 2 squared. What do you mean? whenever you have a squared minus b squared, it's the same as saying a minus b in bracket multiplied by a plus b. Is that true? Yes. Now look at it. What do we have here? We have cos 4x plus 4 change in x squared. We can call this our a. And then we have minus. We have cos 4x, all in bracket, squared. We can call this our b, so that it will look like a squared minus b squared. Let's declare it as a variable here. We say, in this case, let a equal to cos 4x plus 4 change in x, and b to be what? Cos 4x. So if we give it this name, look at how it's going to look like. That means in our function now, we have f prime of x is equal to limit as change in x approaches 0. In place of cos 4x plus 4 change in x, all in bracket squared, we write a. That means we are going to have a squared, then minus. In place of cos 4x, we have b. That is going to give us b squared. Isn't it? Yes. So now, here we have a squared minus b squared. And we say that it is the same as what? Difference of 2 squared. We factor it out, or we factorize it. So when we factorize it, we come out with 2 factors, which is x minus b and x plus b. X minus b, which is a minus b, and a plus b. Okay? Here we have a squared minus b squared. We factorize it, we come up with 2 factors, which are a minus b and a plus b. Are we together? So this a squared minus b squared is the same as a minus b in bracket a plus b. Okay? Now remember that we say that a is cos 4x plus 4 change in x, and b is cos 4x. Isn't it? Yes. Now, in this place that we have limit as change in x approaches 0, a minus b in bracket a plus b in bracket all over change in x. Let's bring it back. So bringing it back, we're going to have f prime of x is equal to limit as change in x approaches 0, a minus b. A is cos 4x plus 4 change in x, minus b is cos 4x in bracket. That is the first bracket. Then the second bracket, we have cos. A is cos 4x plus 4 change in x, plus b is cos 4x. Put it all in bracket all over change in x. Call this equation 5. Are we together? I think you understand how we get to this level, right? Good. So in this case, we're going to apply some few things from trigonometry. So in trigonometry, there is what we call sum to product formula. Sum, you convert it to product. Okay? Look at it. What we have here is cos. Cos 4x plus 4 change in x minus cos 4x, right? We are going to apply something that looks like this, and it is called cos x plus cos y. This is sum, cos x plus cos y. So this sum, we can turn it, or we can convert it to product. So converting it to product, we say is the same as saying 2 cos x plus y all over 2 multiplied by cos x minus y all over 2. Are we together? So this is called sum to product formula. And then when you come to difference or subtraction, where you have cos x minus cos y, it's going to give you minus 2 sine x plus y all over 2 multiplied by sine x minus y all over 2. Yes, please, this formula is very important, and I want you to remember it. Okay? So long this particular question is concerned, okay, you need this formula. In as much you are going to solve this using the first principle or by definition, you need to master this, okay? I want you to study this and know the pattern that it follows. Cos x plus cos y is equal to 2 cos x plus y all over 2 multiplied by cos x minus y all over 2, right? And then we will have the difference cos x minus cos y is equal to minus 2 sine x plus y all over 2 sine x minus y all over 2. So here we say that for the sum we have cos. Then the second part is negative. Then for difference x minus y we have sine. And then we have negative minus 2. And then the other part is also minus. It's very simple to remember. Are we together? Yes. Now let's go. So now, when you look at our numerator, we have cos 4x plus 4 change in x minus cos 4x. Okay? Now, this is what we want to combine and turn it to product. This first bracket is the difference, while the other one is the what? Is the sum. So we want to convert it to what? To product. Okay? Now, look at it very well. We agree with me that we can say that this 4x plus 4 change in x is our x. Is our what? Is our x. Look at it very well. Cos, we have cos, right? And we are saying cos x plus cos y. But in this case, we have cos 4x plus 4 change in x. We can regard it as our x. And then the second part, we have cos 4x. We can regard it as our what? As our y. So we are declaring a variable here. We say 4x plus 4 change in x should be our what? Our x. Because of this formula we are employing here. And then 4x should be our what? Our y. Are we together? Yes. Now look at this. In this numerator, we have the difference, right? So we are going to use the difference, the second one that says cos x minus cos y, because that is, we are having minus there. So that means we are going to apply the sum to product formula, which says minus 2 sine x plus y. What is x? X is 4x plus 4 change in x plus y. And what is y? Y is 4x all over 2 multiplied by sine x minus y. What is x? 4x plus 4 change in x minus, what is y? 4x all over 2. Then multiply by, that is the first one now. The second part now, which is what? Which is the sum. And then the sum says 2 cos x plus y. X plus y. So what is x plus y? X is 4x plus 4 change in x plus y is 4x all over 2. Then multiply by cos x minus y. What is x? 4x plus 4 change in x, then minus y, and y is 4x all over 2. Are we together? Yes. So now look at this. Look at it. It's beautifully written this way. We have f prime of x is equal to limit as change in x approaches 0 minus 2 sine 4x plus 4 change in x plus 4x all over 2 multiplied by sine 4x plus 4 change in x minus 4x all over 2 in bracket. This is for the first part. Multiply by the second part. 2 cos 4x plus 4 change in x plus 4x all over 2 multiply by cos 4x plus 4 change in x minus 4x all over 2. Okay, now let's simplify each and every one of them. So we're going to have f prime of x is equal to limit as change in x approaches 0. In the first part, where we have minus 2 sine, where we say 4x plus 4x is going to give us 8x. Then we have plus 4 change in x all over 2. Then the second part of it, sine. Here we have 4x minus 4x, which is 0. Then we're going to have 4 change in x remaining all over 2. This is the first part. Then the other bracket, big bracket, we have 2 cos. When you say 4x plus 4x, the same 8x plus 4 change in x all over 2. Right? Yes. Multiply by cos. When you say 4x minus 4x, it's going to give you 0. Then we're going to be left with 4 changing x all over 2. Are we together? Yes. So now look at it. We're going to, in this numerator, this inside bracket, we will have 8x plus 4 changing x. We're going to factor out 2. Okay? So when you factor out 2, what are we going to have? We're going to have f prime of x is equal to limit at changing x approaches 0 minus 2 sine. Factor out 2, we're going to have 2 open bracket 4x plus 2 changing x all over 2. Then sine 4x times 4 changing x all over 2. That is the first bracket. Open another bracket 2 cos. Factor out 2 again. We have 2 open bracket 4x plus 2 changing x all over 2. Then multiply by cos 4 changing x all over 2. Okay, now let's divide. Here we're having 2 at the numerator and 2 in the denominator. They will cancel out. And here we're having 4 changing x all over 2. 4 divided by 2 is going to give you 2 changing x. And then also the other one. So after simplifying, look at what we have here. We have f prime of x is equal to limit as changing x approaches 0 minus 2 sine. Here we have 4x plus 2 changing x multiplied by sine 2 changing x multiplied by 2 cos 4x plus 2 changing x multiplied by cos 2 changing x. Hello, are we together? Yes. Now let's go. Here we have f prime of x is equal to limit as changing x approaches 0. We are going to split this into 2. So splitting it into 2, look at how we're going to write it. We're going to have minus 2 sine 4x plus 2 changing x multiplied by sine 2 changing x all over changing x multiplied by 2 cos 4x plus 2 changing x cos 2 changing x. Hello. Yes. Now look at this. Here, pay attention to where you are bringing changing x to. It should be to the side that is having sine, so that you are going to evaluate the limit. Because if you place it on the other side where you have cos, the other side is going to be 0. Hello, I don't know if you understand. So we bring changing x to the part that is having sine, so that we can evaluate it very well. If you take it to the other side is going to give you 0, and everything is going to lead to 0. Okay, so we split this carefully. So as we splitted it into 2 like this, now we take the limit of these 2 terms, because by definition the limit like this is still the same, right? So we're going to take the limit. So when we take the limit, we're going to have f prime of x is equal to limit as changing x approaches 0 minus 2 sine 4x plus 2 changing x multiplied by sine 2 changing x all over changing x multiplied by limit as changing x approaches 0 2 cos 4x plus 2 changing x multiplied by cos 2 changing x. Hello. Yes. Now look at it. In this first part, we are also going to split it into 2 again. Splitting it into 2, look at the way we are going to write it. We are going to say that it is the same as saying limit as changing x approaches 0 minus 2 sine 4x plus 2 changing x multiplied by sine 2 changing x all over changing x. Hello. Do you see this expression? It's still the same. When you multiply it, it will give you the same as they are both, right? Yes. Then we have multiply by limit at changing x approaches 0, 2 cos 4x plus 2 changing x multiplied by cos 2 changing x, right? So this first part, we take their limit also again. We are going to have limit at changing x approaches 0 minus 2 sine 4x plus 2 changing x multiplied by limit at changing x approaches 0 sine 2 changing x all over changing x multiplied by limit at changing x approaches 0 2 cos 4x plus 2 changing x multiplied by cos 2 changing x. All right. Yes. So we go further and evaluate finally now. All right. So anywhere we see change in x, we replace it with 0. All right. We are taking the limit now. Now let's go. But before that, I want you to record that limit as x approaches 0, sin x all over x is equal to 1. Hello, are we together? Recall that limit as x approaches 0, sin x all over x is 1. Likewise, limit as change in x approaches 0, sin 2 change in x all over change in x is going to give you 2. Hello, yes, it's going to give you 2. So therefore, in this case, here we have f prime of x is equal to limit as change in x approaches 0 minus 2 sin 4x plus change in x. Now what are we going to write? We're going to write 0, right? 2 open bracket 0 multiplied by limit as change in x approaches 0 sin 2 change in x all over change in x multiplied by limit as change in x approaches 0 2 cos 4x plus 2. In place of change in x, we write 0 multiplied by cos 2. In place of change in x, we write 0. Okay, so simplify now. In the first part, we have minus 2 sin 4x. 2 times 0 is 0. Then 4x plus 0 is what? 4x. So the first part is giving us minus 2 sin 4x. Right? Good. The next one, limit as change in x approaches 0. Sin 2 change in x all over change in x is giving us what? 2. Then multiply by the other part, we have 2 cos 4x plus 2 multiplied by 0 is 0. So 4x plus 0 is what? Is 4x. So here we have 2 cos 4x, and then in the other part we have cos 2 times 0 is 0. So here we have cos 0. So after evaluating the limit, this is what we have. We have f prime of x is equal to minus 2 sin 4x multiplied by 2 multiplied by 2 cos 4x cos 0. Now when you say cos 0, what it's going to give you is going to give you 1. So therefore we have f prime of x is equal to minus 2 sin 4x. Here we have 2 times 2, we have 4. Then we have 4 cos 4x. Here we have minus 2 times 4 is going to give you minus 8. So therefore, f prime of x is equal to minus 8 sin 4x cos 4x. All right? Yes. So when you evaluate the derivative of y equal to cos squared 4x, right, with respect to x, is going to give you minus 8 sin 4x cos 4x. Hello. Yes, I want you can use any other method. It's going to give you the same thing like this. So this is how to find the derivative of a function like this using the first principle or by definition. Okay? Yes. Please, I want you to watch this over and over again so that you will understand it properly. There is nothing difficult on this, right? I want you to pay attention and watch it again. Thank you very much for watching. Please, if you are new to our YouTube channel, do well to subscribe. If you have not, like and share our videos and stay blessed. Thank you.